If we want to solve these expressions in the opposite direction, but we can only move one face at a time, what should we do? Here is a container. Put the first one in the container, then the second one, and so on. After placing them, pop the top one out of this time, then the second one, and so on. In this way, these are changed in order. In fact, this container is called a stack. It has only one opening. Therefore, there are only two operations. One is push, and the other is pop. Although there are only two simple operations, however, we can achieve more complex effects. Let's talk about two examples. The first one is to check whether the parentheses in the string match. Second, how does the machine efficiently read and calculate such equations? The first one, suppose there is now a set of parentheses. However, the machines can only be checked one by one. How can it be done by checking only once? That is, the time complexity is big O n, and n is the length of the string. Now, with the help of the stack, the first one is the left parenthesis. Then push it to the stack. That is, all opening parentheses do the same. Then the second one is also an opening parenthesis and continues to be pushed into the stack. Then the same goes to the stack. The fourth is the right parenthesis. All right parentheses must be popped from the top of the stack, and compared with the fourth, it is found that the pairing is successful. Then the next closing parenthesis, popped from the stack, also matches. The last closing parenthesis is popped out of the stack, and the pairing is successful. The inspection is over. The second example is how the computer runs such a calculation. We know that we must first calculate the formula in the brackets, multiply the result by 3, and finally add it to 1. Then the simple way is to scan the formula first, check whether there are parentheses, and calculate first. Then starting from the beginning, check whether there is a multiplication or division sign. Finally, scan again to calculate the plus or minus sign. This efficiency will be relatively low. The more effective way is to first switch to an intermediate state, remove the parentheses, and put the operator after the number. We call the operator in the middle of the infix expression. The operator is followed by the postfix expression. So how to make the machine realize the conversion? First, according to the rules, all numbers are output directly. So scan the first number, output. Then came the plus sign. The second rule is that operators who have a higher priority than those in the stack should be pushed into the stack, or the stack is empty. Therefore, the plus sign is pushed into the stack. Then comes the left parenthesis. The third rule is that all opening parentheses must be pushed into the stack. Therefore, the left parenthesis is pushed into the stack. The next, number 6, according to the first one, also output. Then there is the plus sign. According to the fourth rule, if the stack contains a left parenthesis, all operators should be pushed into the stack. Therefore, the plus sign is pushed into the stack. Next, the number 2 is output directly. Then there is the right parenthesis. Rule 5. If it is the right parenthesis, the stack is popped continuously until the left parenthesis is encountered. So pop the plus sign, hit the left parenthesis, and end. Next is multiplication sign. According to the rule 2, into the stack. The last is 3, output. Finally, pop up all the stacks one by one. We have the postfix expression. Finally, we use the stack again. Push all the numbers on the stack. Pop the stack twice if encounter an operator. Perform calculations and push the result on the stack. Then 3 is also pushed into the stack. Then there is the multiplication sign, turning the top 2 of the stack into 24. The final sum is 25. End the calculation.